Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today for exam FM on financial mathematics. Your company has a liability which calls for a single payment of $1,000 due in 10 years, and it funds it with a 1-year zero-coupon bond with a price of $200 and a 20-year zero-coupon bond with a price of $800. Current continuously compounded interest rate is 4% and the yield curve is flat. Calculate the ratio of the Macaulay duration of the Macaulay to the Macaulay convexity of your company's surplus. And here's the solution. The present value of the liability is $1,000 discounted over 10 years at continuous compounded interest rate of 4%, or force of interest of 4%. It's approximately 670.32. And the assets are worth 1,000, so the current surplus is the difference of the two, which is 329.68. Macaulay duration of an individual cash flow is its time to payment. The Macaulay duration of a surplus is the weighted average of the durations of individual cash flows. So here, 200 as a fraction of the value of the surplus times 1, because 200 is the amount invested in a 1-year zero-coupon bond, minus 670.32 over 329.69. The negative allocation is to the liabilities, negative 670.32. And as a fraction of the surplus, that's negative 670.32 over 329.68, the amount of the surplus. This is multiplied by 10, because 10 is the Macaulay duration of the liability cash flow at time 10. Plus 800 over 329.68 times 20. 800 is the value of the 20-year zero-coupon bond. Its Macaulay duration is 20. And as a fraction of the surplus, that's 800 divided by 329.68. So these are positive and negative fractions, but they add up to 1, and it's just a weighted average, and that's approximately 28.8061. So the important thing is that this rule about the weighted average of Macaulay durations of individual cash flows, it applies also to negative allocations, which is the case here. Macaulay convexity of an individual cash flow is the square of its time to payment, and Macaulay convexity of the surplus is the weighted average of individual cash flows convexities. In this case, 200 over 329.68 times 1 squared minus 670.32 over 329.68 times 10 squared plus 800 over 329.68 times 20 squared. And that's approximately 767.9204, and the ratio of the two is approximately 0.0375, which is answer A. Please remember this is copyrighted material, all rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited. Good luck in your studies and good luck on the test.